So I want to thank everybody for taking time out of your day to spend an hour with us for today's third and final installment of What's New in SolidWorks 2017 presented by DASI Solutions. So if you haven't met us yet, DASI Solutions got a bit bigger by joining up with a really mature team full of professionals out on the West Coast called Digital Dimensions. And what that's done for us as a whole is it's given us both East Coast and West Coast coverage. And we now have 12-hour tech support hours directly through DASI Solutions. So East Coast is 8 a.m. to 8 p.m. and West Coast is 5 a.m. to 5 p.m. My name is Darin DASI. I've been with DASI Solutions and SolidWorks for just over 20 years. I've got a couple of nice accolades over my career, but I'm most proud of how long I've been married and my two little girls. We got some chickens in my house. It's a pretty interesting scene here, but the last summer I've also earned the moniker of Treehouse Master. That's because I spend a lot of my time creating things like this. Now, the reason I'm showing this is not just because I'm a big home improvement guy, but because everything that I do starts in SolidWorks. So what I did here is I used the weldments technology and some wood frame profiles instead of steel or extruded profiles, and basically got the same type of cut list, but it allows me to go ahead and test things before I actually start creating anything. Getting the proper bill of materials, getting my materials from the local home stores, and then basically making sure that things look the way I want them to look before I get started. Now I'm in the middle of a project here, going to be wrapping it up in the next weekend. Another designed in SolidWorks preview here so I can test the fit and function of all of the cabinetry and devices that we've purchased. So it's not just a job for me, it's something that I do on a day-to-day basis. Now if you do have access to SolidWorks through a home use license, you can also load it on your home computer and do any type of home project that you'd like to do as well. In the end, it's going to be stick time. It's just going to make you more mature and better with the product. So SolidWorks 2017 has been delivering a lot of new functionality for every gamut of design. Now, in the last few presentations, we've covered things like our innovative new technologies and a lot of the design and validation aspects. Today, we're going to be covering a little bit more of the collaborate and the make and build. Now we're using a data set from one of our customers here because it really fits the bill for everything that SolidWorks does. We've got printed circuit boards and electrical, mechanical components, and aesthetically pleasing consumer design components. Everything really under the sun that we cover. Now when a company like yourselves are looking at our products, we bucket our functionality into these nice little buzzwords, but you're trying to take our capabilities and really perform a goal and a final design solution. So when we're talking about mechanical design, this particular company is trying to build their device, which happens to be a myoelectric orthotic. And of course, this will be unique to each of our customers. Now, they utilize the electrical design to make sure that all these mechanisms and components talk to each other, reading pulses from the muscles, translating those into signals with the circuit board, and then making those actuate through the servos. When we're talking validation, well, frankly, every design has some components that are very critical to its function, and we want to make sure up front when it's easy to make design changes that those devices or those parts are going to perform as expected and not only be strong enough but also make sure that they're not over-designed. In the case of this type of a device, of course, it's worn by a user, so weight is definitely a primary concern, and we want to conserve as much as we can while still having functional and strong components. Now, collaboration happens in every aspect, and it's different between company to company depending on who your customer is or who your input comes from. But with a device like this, we have to have everybody talking together, whether it's the suppliers of the components, the doctors who are prescribing this as an aid, and then the patients that have to wear it and need feedback to come to the company in order to refine the designs to the best of their abilities. And all of this data through all of this communication chain must be managed. Whether you're a one-person shop or whether you're a giant distributed workforce, managing the data and having data management access is of paramount need. Now, when you have things like FDA or USDA types of concerns to deal with, those types of things, as well as military and ITAR compliances, can all be covered with our PDM applications. Now, of course, all of this has to be completed at the absolute lowest cost possible. So everything needs to be efficient, and we need to not have to duplicate efforts or have to redo anything in order to get to our final design goal. So as I said, we've talked about innovation and design and validation up to this point. In part 3, we're going to finish up with our collaboration and manage and build nodes. So let's just go ahead and get started. So for collaboration, we're going to show a little bit of our new eDrawings capabilities, as well as something we've had in the software for quite a few years called Treehouse. Now, costing is a particularly interesting topic because if you do spend a lot of your time estimating the cost of a product, costing can benefit you in a very, very big way. We'll talk about that as we get to it. Managing and building, of course, is the final result of all of this exercise in creating digital media. So we need to still be able to communicate whether you're still doing it with traditional 2D drawings or whether you've taken the leap to more of a drawing-less manufacturing process where model-based definition comes into play. Again, all this data and all the different disciplines need to be connected to each other and easily searchable, so SolidWorks PDM is an incredibly powerful tool to integrate into all of these aspects. Now, some of you make product out there if you're in military or oil and gas refinery or a lot of other high production good, precision good creation gamuts, then basically SolidWorks inspection is something you're probably familiar with, or at least the inspection process. We'll talk about ballooning drawings and being able to get first article inspection documents out with a minimal amount of clicks in SolidWorks. And then finally, we'll finish up with digital manufacturing in the form of 3D printing. So let's get started with eDrawings. So eDrawings is really becoming the viewer of choice for not just SolidWorks and 2D drawings and Pro E files as it's always been. We can read several new native CAD formats and a lot of neutral formats as well. So the ability to read Inventor and CATIA V5, which is a particularly popular one, as well as IGES and step files. And we have this new standard, it's called AP242. This actually includes PMI data. So if you have a software that's sending you files that has the ability to create this PMI data, exporting in this file format will support those 3D annotated model-based definition or PMI type objects. And then we've improved things when it comes to Pro E/Creo and this new 3D XML, which is our CATIA V6 platform. So let's look at a couple of these. When you're in eDrawings, File Open, again, is the way to go throughout any Windows application. But you'll notice in our file type list, there's several new ones. So we get into things like STL files, Inventor, CATIA V5 and V6, as well as IGES and step files. And these are all very, very popular. Now, if we're looking at just a regular SolidWorks file, of course, we're going to have a lot better performance with this particular version than we have in years past. Now, it's really not going to translate very well through the go-to, but essentially the performance in rotating, translating, exploded views and such is markedly better than it has been in years past. So you can see I've got a lot of components on the screen and quite a bit of detail. Now, if we want to see anything else about this, of course, you've got your components list over here on the right, and by selecting any one of those components, you'll get some crosstalk out there in the graphics area. Not to mention what we did last year, where we went ahead and made sure that not only the name of the file, tooltips, but also the description in this case, the verbose elbow membrane graphic overlay description. So a lot of those things are very nice additions. Now when we go ahead and open up other types of files, in this case what I want to do is open up one we saw in part 2 during our 3D interconnect demonstration, and that was an Autodesk Inventor file. Now this happens to be the Inventor assembly that we used in the beginning part of that demonstration, and I just want you to see right here that this is in fact the same type of data. But even though it's not SolidWorks native data, that doesn't prevent us from doing fairly normal things with it. In this aspect, I just want to show you that inside has those 8 battery cells as we saw before. And even though this wasn't created natively in SolidWorks, that doesn't prevent us from viewing this type of data and measuring directly off of it. So a lot of different file types, native CAD formats, as well as the traditional SolidWorks eDrawing and DWG that we've always read. Now one of the newer ones, as I've mentioned, is Step AP242. Now this file type actually supports PMI data, and traditionally you'll get this out of a product like CATIA V5 and a few others. But when I open up this file, it's a translatable file that still gives us geometry, but again has the added benefits of the 3D annotations. Now this is going to play into a little bit later when I start talking about model-based definition, because then you're going to see exactly where this information comes from. But this file type being neutral gives us the capability to communicate with people in quality control who maybe only have viewer capabilities, but still need to be able to see the fully annotated version of this file. In this case, we're skipping 2D drawings and going directly to 3D annotation so that there's not an extra file type to manage, but it still gives us all of the manufacturing and datums and surface finish marks and full GD&T. Again, I'll show this in just a little bit when we cover SolidWorks model-based definition. A couple of other things that happen to be here is the ability to go ahead and open files read-only so that you don't have users with eDrawings Professional inadvertently making changes to your file. Now, we've also got this password protection, which is great. Of course, when you're sending files out, you can go ahead and encrypt them to a point where only people with the password would be able to view those. And new support for something called Google Cardboard. Now, you can get these for about $8 online, or you can get some basic templates that you can cut out yourself. But what Google Cardboard amounts to is the ability to go ahead and take our eDrawings platform in an iPhone or an Android device and basically allowing to go stereoscope. When you slide it into the cardboard box, it'll go ahead and make it so that as you view, it'll give you more of an immersive 3D type virtual reality mode. Very, very cool stuff. Again, that is going to be with eDrawings Professional on any iDevice or Android device. Now, Treehouse is something that we've had in the software for quite some time. And what Treehouse amounts to is a tool that allows us to really glean some structure off of the assemblies that we might see in more of a flat system when we're looking at them in Windows. By dropping an assembly into our Treehouse window, it'll show the hierarchy and all of the thumbnails for all of the components, as well as things like the quantities, access to property information, and whether drawings exist or not. Now, in Treehouse 2017, we now automatically include drawings on import. So when I open up an assembly and that file or subcomponents or subassemblies have drawings, we're going to see those in their drawer directly on the component. We can also now open this structure in Excel. By exporting it out to an Excel file, it's going to give you more of a tabular-based Excel spreadsheet with this very same hierarchy. Now, the view that you see in this lower right-hand corner here is also something that can be printed. Now, when you print, of course, you can print it directly to a printer, but you can also print to PDF, which is very convenient. That file can be shared with anybody, and they will physically see the graphics and the hierarchy. Although not interactive, it will still give you exactly the structure in more of a graphical roadmap. This is located in your SolidWorks install directory under your programs under SolidWorks Tools. Now, SolidWorks costing. Once again, if any of you spend any amount of time during your week repetitively costing a component, what you're basically doing is taking the costs that it is for you to create operations or to post-process or to set up a machine or to anodize a part or powder coat it. Any of these things all have cost. Well, by knowing this data, you can plug it into a SolidWorks costing template and effectively click a single button, and it will kick you out a nice estimation of exactly what your part is going to cost. Now, this works for machined parts, whether they happen to be milled or turned. Works for sheet metal parts because bends have a cost, and dollars per inch on a cutter like a water jet or a plasma also has a cost. But you can also do things like 3D printed parts or plastic injection molded parts. In each of these aspects, there's a scrap value that potentially can lead into reclamation values, as well as the ability to cost purchased components. Now, what it will do is give you a complete cost run-up on an assembly using a SolidWorks Premium license, or you can do it part by part on a professional license. With SolidWorks 2017, we've upped costing when it comes to sheet metal, where we now see the bounding box preview of the last sheet used. Now, this is in the case that I want to take apart and I want to make 50 of them. We know what the stock is, we know what the bounding box is going to be, so we know what the layout's going to be. And in this case, seeing the last sheet indicates the amount of scrap that we might have due to the nesting operation. We've also now added rules-based costing for sheet metal parts, something we had for milled and machined parts before. Now, what rules-based really comes down to is if something happens, then do this. So in this case, you see things like if the longest edge of the stock of the bounding box is a certain size, then add a cost to it because we have to use a larger machine or we have to use a bigger piece of material. Any of these types of things can be captured and automatically applied to a file just simply based on its geometry. Now, the subassemblies we've always costed, but now we can go ahead and actually nest or expand out that tree so that you can see the subcomponents and the overall cost of the upper level assembly itself. Now, purchased parts can have an overriding cost value, so if you do get fasteners, those fasteners can have an out of the box cost or an individual piece part cost as well. Templates are always customizable. When we export the file, it's going to give us the images and the tables that were used and all of the information that led to the cost run-up itself. And then finally with this, we also have the ability now to do multiple quantity costing reports. Now, of course, this is effective because the same setup might be true, but if you run 50 or 100 or up to 500, obviously we amortize that setup cost over the multiple quantities. So this allows us to get a little bit more of a part run injection into the overall cost value. One more thing on this one last. When you're filling out these templates, things can get fairly repetitive. So easily being able to select columns and rows and choosing copy and paste allows you to very effectively build these templates when it comes to a large amount of potential materials and stock sizes available in your templates. Now, one thing that's been happening as of late with mysolidworks.com is companies who do these types of costing templates, more importantly, companies who actually manufacture parts like sheet metal parts, are now placing themselves on the manufacturer's network on mysolidworks.com. Now, you can create your MySolidWorks page if you haven't already done so by simply logging into mysolidworks.com and providing your SolidWorks serial number. But what this gives you access to are companies who have already gone through the process of making costing templates based on how they produce materials. Now, for this example, Abbotsville Industries and Ability Engineering, you could take their costing template in a read-only form, run it on your sheet metal parts, and it will tell you exactly how much Abbotsville is going to go ahead and charge you for their parts. So by them providing you with costing information, you can get estimations directly from them of how much they'll charge you to produce these. It's a great link up between people looking for manufacturing capabilities and those people who have manufacturing capabilities within our SolidWorks community. Lastly, we're going to go ahead and get into our manage and build aspects. Now, the first thing we need to do is drawings. And I'm a little more, facetious when I talk about drawings these days because I really feel that we've built drawings for years and years because that's what people expect. But we're getting more and more tools within our software that allow us to eliminate 2D drawings from the design process altogether. We'll talk about that a little bit with manufacturing with model-based definition. But for what we need to do with drawings, we're going to go ahead and get into some of the really beautiful enhancements for what we've done all along for communication. So the first thing we're going to talk about here is outlining of the section view. It's a nifty little function that tells us exactly where the cutting plane cuts, so we can differentiate easily between model edges and then those edges that are produced due to a section. Some great things with our crop view capabilities and the ability to modify the way the edges of those views look, as well as one of my favorite things in this entire release, mirroring drawing views. Let's go right into this. So the data set that we've been using here is an orthotic for obviously a person's arm. And this is absolutely quintessential, the easiest example of a part that needs a left hand or a right hand version, quite literally. Now, over the years, SolidWorks has given us many, many different ways to deal with mirroring parts, whether it's mirroring this entire assembly within an assembly, whether it's taking an individual component and saving it as a mirror, and then a whole bunch of choices about whether we keep it linked to the original or whether we divorce it from the original, and how the annotations are then going to go ahead and trickle down to those drawings. Well, this example we're going to show you here just a little bit about mirroring is absolutely the most elegant approach possible for this type of a situation. First, what we're going to get into, though, is just the basics of this drawing. Now, when we look at a lot of the drawing views that we have on the screen here, what we're going to do is just go ahead and emphasize this section view that we see in the upper right-hand corner. So with what we have there, all I have to do is easily select inside the view, but not on the part. We have some new properties over in our property manager. The one I'm going to show you right now is called Emphasize Outline. What that will do is take the section cut, and it will thicken that on screen. So once again, it's very easy to differentiate between part edges now and edges that are there due to the section view. Now, of course, we have a child view here, which is a detail view. By moving over to that view on the drawing, you'll see that it also inherits the exact same behavior visually. Now, this view itself also has a couple of other nice functions to it. Not everybody likes to see this edge here, those edges that are produced based on the profile that we used for our detail view, in this case a circle. So we have a new capability now by selecting inside that view but not on the part called No Outline. What that will do is simply remove the edges that are there as a result of where our circle or square or spline shape cuts through the part, and gets rid of those edges altogether. Now, if this isn't your cup of tea, there's another way to approach this. We have a new function here also called jagged outline. That will keep those edges, but that will allow us to go ahead and make them more or less jagged using our slider, just to emphasize the fact that that is a broken off piece of this part. Now, when it comes down to the actual thickness of this line, this is a section, or a session, excuse me, this is a property that you have in your tools and options. When we go to tools and options, this is a document property. So it lives with this file, but it's down here under our line font. It's called Emphasize Section Outline. Now I'm going to change this to about twice the thickness just so you can really get a feel for this. Once we say OK, of course it's going to change here on the detail view, but it also changes over on the main drawing view in the upper right hand corner. Now up here in the upper left, there's a couple of things I want to note. First of all, when you get into tables, you can now lock the column widths of these tables so that the user wouldn't be able to go ahead and pull them wider or make them more narrow. It gives us a lot more control over formatting from drawing to drawing. Another nice thing that I can now do is also go ahead and link my notes to cells within this table. Now this is done by using the typical note tool, but instead of actually placing the note and linking to a property, we're going to use this button right here called Link Table Cell. First, let's go ahead and throw the note on the screen, and I'll do that just by throwing a couple of leaders in. And then we'll place our note. Now instead of typing any text, we'll go over to the Property Manager and select that button on the new row there called Link Table Cell. What I can now do is go ahead and select anywhere in the table, and you'll see that we get this associative property. So that's a really great thing right there. I'll drop another one on there just for emphasis. But what we now have are things that are linked directly to the cell. So as a user, if I went ahead and double-clicked on a cell and wanted to change that value, that looks pretty good. Once I click outside, you'll see the associativity kick in, and all of my notes automatically inherit that value. Now, one thing I noticed when I was setting up for this that I thought was interesting, and maybe some of you saw this as well, was the way that I added these two leaders on the fly as creating this note. And this is something that's actually been in the software for a while, but was something I really forgot about a long time ago. So to do that, in case you were wondering, is as I place the note, if I go ahead and click Place My Leader, before I actually click to insert the note text, hold down the Control key. That will enable you to put several other leaders, and then once you want to, you can release the Control key and then place your note and type whatever you want. Very cool technique, but definitely one of those things that's an ease of use element within SolidWorks. Now, what I have not talked about yet is mirroring of drawing views, and this is the feature that gets me the most excited. So as I mentioned, there's a lot of ways that we've approached this in the past, creating actual 3D geometry and having to deal with the associativity or breaking the links of those geometries. Well, here we have the most elegant way possible. Select your main drawing view, and over in the Property Manager, we have a new Mirror View check. Just by simply selecting the check mark, we'll mirror either horizontally or vertically everything in those views, as well as all of the child views associated with it. You can either mirror horizontally or vertically. You'll see it'll flip those in this direction. And because we're dealing with geometry that's just based on the way the view is shown, I don't have to have a whole nother data set in order to pull this off. In fact, I can go ahead and copy this drawing view, paste it into another location, and I can take just this drawing view and mirror it just so you can really see the emphasis of what we're talking about. Let's do a horizontal there, and I'll place it side by side with the other. No need to reproduce a drawing, no need to have additional files, or worry about what might happen when a change comes into play. Absolutely the most elegant approach to creating mirrored geometries. A couple of other interesting details here is the ability to go ahead and change the sheet format for multiple sheets. Now in this case, if you want to go ahead and right-click and go to Sheet Format, you can change the sheet, but there's a button there that simply says Select Sheets to Modify. Let's just go ahead and do that. So by right-clicking on the drawing, going to the Drawing View Sheet Properties, what we now have is the ability to go ahead and select Sheets to Modify. So if I want to move these over to just a basic C-size sheet, you'll see that this title block has no logo like the one that we see here on Sheet 1. I can choose that, but then I can go ahead and say that I want to change Sheet 1, Sheet 2, Sheet 5, and Sheet 6. Say OK to that, and we'll apply. Confirmation says, do we want to delete these views? Sure do. So now what you see in the lower right-hand corner of this sheet is C-size title block, but without the SolidWorks logo. Same on Sheet 2, Sheet 3 and Sheet 4, however, have been untouched. And then Sheet 5 and Sheet 6, as you can see, do have that logo missing. So that's a really great way to change your sheet templates en masse in a very large tabular type of drawing like this. Really simple stuff. When it comes to communicating, there are different aspects of our community that are really a little bit more forward thinking when it comes to these, or kind of pushing the bleeding edge. Now, for more than 10 years or so, the Department of Defense has been using things like model-based definition or enterprise definition to build in all of the annotations into their 3D body. Their idea is that they don't care what CAD system you design parts in, but as long as we can send somebody a 3D PDF with all these annotations and then a neutral bodied file that they could machine this off of, then essentially it's a black box of data that we can give to anybody and produce proper parts. That's where model-based definition comes in. So what I want to show you today is how to create this type of model-based definition communication off of your existing SolidWorks 3D parts. We're going to do a little polar dimensioning in geometric tolerance types of parts, and we can reuse datums so that we don't have to manually select and hope synchronize datums from face to face and feature to feature. We're also going to talk a lot about how to add dimensions easily to these features, and then create a template that places these different views onto a nice transferable file that's universal to everybody, which is a PDF file. So let's go ahead and look at this inside of SolidWorks. So I'm going to take a part inside of our Myomo Pro, and we're going to use this to go ahead and create communication. Now, one of the reasons that this exists in its current form is that the dimensions that we use to build a part are rarely the dimensions that we use for manufacturing purposes. In a parametric system like ours, generally these dimensions are built to control change, not necessarily to communicate how this part gets produced. So what we're going to do is go ahead and scheme this part for full production, but we're going to do it on the 3D part itself so that we don't have another file that we have to maintain and manage. Now, inside of SolidWorks, if you purchase model-based definition, you'll see this new tool tab up here. Now, we're going to choose a few different things here. The quickest way to get a lot of stuff done is using the auto dimensioning scheme. First thing I want to do here is use some linear tolerancing, but we're going to do GD&T for the tolerance type on this type of pattern. The way that we select things is simply on screen. We'll pick our first face here as datum A. We'll pick this circular hole on the inside there as datum B. And then when you select the features that you want to pattern or want to dimension, it detects things like patterns of holes automatically. By saying OK to this is where the magic happens, and it automatically tolerances the part out with different dimensions for the holes, as well as the GD&T that's all spec'd out with tolerances based on our setup. Now, we also get validation, so you see some faces on my part have turned green. We can turn that on and off as necessary, but it gives us great insight as to whether we have enough dimensioning on our part in order to manufacture. We're going to do another auto dimension scheme. This time, let's go ahead and do it a little bit different. In fact, the one I did prior to that was actually not correct, so I want to delete each of those. But let's get into this one as well. So we'll grab our primary datum here. So there's my first face. Again, second face we're going to reuse just by picking the datum itself. And then again, the feature that we want to use. By picking one hole, it auto detects the rest of those. Once again, it will use that scheming in order to go ahead and place the proper dimensions. Now, what we're doing here is effectively creating all of the annotations to manufacture, but we're also producing this in a way that much mimics the 2D drawing. Down here at the bottom, you'll see a tab called 3D Views, and if I expand that out, what I can do is easily go ahead and move to these positions that are basically standard 2D drawing views. We have the ability to place whatever dimensions we want visible in any of these different directions, and we can also place unique notes views for each one of these different views. Now, on my right side view, I'm going to add some additional details. Here, let's go ahead and do some locating dimensions to give us some simple sizes. It's much easier than in years past because all I have to do here is select model edges instead of the faces we were traditionally using. I can also use my basic dimension tool to do things like this inside and outside arc. Very simple, but all based on the point of view here of our right side plane. I can even go ahead and dimension between reference geometry. So there's a plane on the front of the part, and there's a center of mass icon out here in the middle, which are all selectable and usable in order to go ahead and annotate. Once again, my right side view is now refined to show just the details that I have available to me at this point, and I can change this anytime based on how I would like this to be viewed. Now the way we communicate this is one of two, actually. You can send out an eDrawing with all of this information, and it will have all of the thumbnails and the 3D views that we saw at the bottom, full of all the annotations as well. Or a more traditional method that's going to be more universal, which is the 3D PDF. Now we have the ability to customize these templates all we want. And once we customize them, we can have different areas where a user on the PDF side could actually fill out and save the document. We have areas where it will automatically extract SolidWorks properties, much like it does on a 2D drawing template or in our PDM data cards. And then you can control exactly what views show and on what multiple sheets are available. So inside of SolidWorks and inside of our ModelBased Definition tool, we have this thing called a template editor. Now the template editor is going to go ahead and pull up the full PDF template tool, which allows us to go ahead and make changes and lay this out any way that we want to. Again, we can take properties here that are basically from SolidWorks and they're automatically filling out just as we do in title blocks. You can go ahead and put any types of notes areas or text boxes anywhere that you choose. And you can even have editable areas inside of the PDF as well. Now if we have multiple pages on this one, we can choose to have different views specifically shown and even go ahead and insert a bill of materials table anywhere that is convenient for us. Let me go ahead and pull this up and place it there. So there's a lot of capabilities for the format and the layout to look exactly the way that you would like these to be. Now once we have these things done, we basically just go ahead and produce these by either kicking off once again a PDF or an eDrawing or even just a step file if we just want to create the AP242 file with the PMI data. When we produce our PDF file, you'll notice even at the bottom of this tool I can automatically create and attach that AP242 document and have this file producible by anybody who receives it. Here we're going to use the template that we've created. It happens to be a 2-page template, and I'm going to choose all the views that I want placed in there. Once we accept this, it's going to go ahead and kick off the PDF creation process, which I'm going to throw on my desktop. As soon as this is complete, the PDF file will open up for us. Now this file is not only universally accepted, but it means that people are pretty much aware of how to navigate these. So when we're looking at a PDF file, here we have an area where people can type whatever they like, and this is an editable cell within the PDF file, which is generally a read-only type of document. When I go over to page 2, what you'll notice over on this one is all of my thumbnails on the top, as well as all of my data right down here at the bottom. Let me fit that a little bit better for you. Now by picking any one of these views, like my right side view, you'll be able to see all of the details and dimensions that were there in each of those views. What's great about this particular tool though is that there's crosstalk, which means when I select a dimension, the features associated with that dimension actually highlight. So it's not just a 3D body with cryptic dimensions. Everything that we do here has behavior to it, and we can go ahead and produce this by giving it to anybody who can simply interact by clicking and viewing. Now when we look at these different types of views that are available to us, these are all the single part views that we had. But one of the files that I'd like to pull up for you is one that I actually created back with SolidWorks 2016, just to give you another idea. Now the template that I was editing prior to this was the one that I used for my SolidWorks 2016 data. So what I have here is an assembly and the view of choice on this front view. Through PDFs, you can change the view to any location or position that you'd like, and it easily changes and once again has that crosstalk. So selecting features highlights the holes or the faces that were used to create it. Now on page 2 of this one, this is where I have my 2 model views, and then down here at the bottom is where we have our bill of materials. The bill of materials is a bidirectional piece of feedback, so as I select a component, you'll see the line item in the bill of materials actually highlights. If we select it in the bill of materials, you'll see out there in the graphics window, we get some feedback there as well. So there's the components, there's the main pieces there, and as we select, we get a great view of what we're looking at. So it is a fantastic way to be able to communicate with users out there and show them exactly what's happening with your 3D data, but by not having to send them all of the CAD data, both editable and large when it comes to file sizes. So this is a tool that's going to be gaining more momentum as the years go by, and as more people realize that they're really producing 2D drawings because of the way we've always communicated, but not necessarily because it's the best way we communicate. When you think about it, you're taking 3D parts and you're flattening them onto a 2D drawing, and then you're handing that 2D drawing to somebody and saying, now make me a 3D part from this. Well, the way somebody interpolates that data, there's really a lot of room for error. So why go to 2D in the first place when 3D is just as an effective way of communicating the same type of information? Already mentioned on this, we can create and attach the AP242 file immediately, as well as display sketches in our 3D PDF. Now, one thing that also comes into play is changeability. And when we have these 3D annotations, of course, we've had Drawing Compare for quite a few years with SolidWorks. So if we're trying to get you away from making drawings, well, of course, we want to give you a way to compare those 3D files. So we also have a PMI wizard, which essentially shows us what is unique to each file, what's common between both files, and gives you the ability to see those changes side by side on the screen. SolidWorks PDM has also been undergoing quite a bit of a cosmetic change, as well as last year when we introduced SolidWorks PDM Standard, which is the little brother to SolidWorks PDM Professional. Well, new to SolidWorks PDM Professional, we now have latest version overwrite. Now, this is something that only authorized users will be allowed to do, and it is a permission, but it's for those aspects where maybe you just want to tweak a property of a part and don't want to do an entire lifecycle change, or it's an approved file that you don't necessarily want to have to run through the approval process again. So for those innocuous changes where you just want to tweak a file but don't need a complete version history of it, latest version overwrite is definitely what you've been waiting for. When it comes to the way history is created and then rolled back in some cases, we now have some structuring capabilities where when we roll back a drawing, we also roll back all of the references to an as-built version. It's much better than just rolling back the individual document on an island. Database replication is now new and similar to, but not quite the same as, vault replication. Database replication is a method of actually having the SQL database housed locally to everybody. Now, we've done this with our archive server, which is the actual repository of all the data files. And that's in an effort to speed access to data in distributed work environments. Now, of course, pipelines to places like China or India, those aren't going to be as fast as they would if you're here in the continental US. But with database replication, we can now remove even more of that latency by having the SQL information locally as well. You'll notice that it's all read-write directly from the main database housed in the home location, but you can also get some read-only capabilities where those will trickle down from other servers and have that SQL database, again, local and under the roof of the people trying to access the data. New to our PDM Web 2 capabilities is now a universal viewer. We call this WebGL because we're no longer locked into things like ActiveX types of viewers, which gives us browser independence. So whether you're on Firefox or Chrome or using Safari, you're still going to be able to see and preview these type of data. General document preview has also been added. So we only did CAD files before, but now you have the ability to preview the same types of documents that you would in a Windows Explorer Vault view. So that's going to be general files, Word, Office documents, images, videos, those types of things. Through our web access, you can now restrict download capabilities. Now, you've always been able to restrict somebody from checking in a file, but when you give them web access, they've been able to download and at least view the file from that point. Here, because of our viewer capabilities, there's no need to have full download capabilities, so now you may restrict that. Tasks have also undergone a nice enhancement because of the different file types that we can now produce. So we can now run an automatic 3D PDF task to produce these model-based definition files. You choose the types of views that you want exported and the themes or the templates that we're going to use, and those will automatically be created through an on-demand process or during an automatic transition through a workflow. The same is true with Office files to PDFs, as well as DWG or DXF files to PDFs. So again, neutral files to be able to view out in the industry, but produced from these different disciplined files from Office and from old 2D DXF DWG files. Now, if you're into naming these files in a very strategic way, we can also add these variables, anything that you would produce through the data card or that are searchable variables, and they can be injected into the output file names. So in creative ways, they're going to give you much more information with a verbose file name than you would have without access to the properties themselves. We've also added enhancements to the preview window inside the Windows Explorer Vault view. This Properties tab to the right-hand side can now be collapsed completely and have an entire eDrawings viewer window or General Documents viewing pane instead. For those IT individuals out there who shudder at new service packs, we now have the ability to run with the clients and the servers on different service packs. Now, generally when a service pack comes out, the IT staff needs to get not only the server updated immediately, but all of the users, because once the server was updated, the users no longer had access to the data. So this enables us to have less of a firestorm when it comes to these service packs, and the IT staff can now update the computers in a much more relaxed scenario. Now, for those companies who already own SQL, whether it's a standard or enterprise license, you can now purchase lower cost editor, contributor, and viewer packs because they don't have to include the SQL license royalties. So great for, again, everybody out there that already has SQL installed and implemented and has available licenses to allocate towards SolidWorks PDM. SolidWorks Inspection has been growing over the last few years as well. And as I mentioned, for those companies who make large run, high precision goods, we need to make sure that those parts coming off the line are speccing out to the way they were designed. Now, generally in quality control, we have a particular number of runs. We pull some random samples, and we'll hit those with a coordinate measuring machine or a laser measurer and be able to see whether the design data and the manufacturing data are matching. Now, this process, though fairly simple, is ripe with the ability to have manual error. Most of the times, these documents are manually ballooned, and then those balloon numbers, as well as the primary value of the dimension, the tolerance value, and then the arithmetic of the upper and lower limits are all manually keyed into a spreadsheet. Now, the spreadsheet is generally then given to quality control so that as they coordinate measure the samples, they'll be able to input in that spreadsheet what they actually measured to. Again, it's a very straightforward and monotonous process, but there's many, many, many places where an error can take place. So SolidWorks Inspection does this in just a series of a couple of button picks. What we've added this time around is more control when it comes to the ballooning, where you can auto balloon or you can be very manual and select the parts or the annotations and characteristics that you'd like to balloon. Not only that, but you can lock the balloon numbers so that even when dimensions are removed or new ones are added, the balloon numbers do not change sequentially. Support for this new VDA balloon standard. This looks a lot like the type of icons that you would see when you're clicking on a map on a phone or on Google. And then mouse wheel. For those of you who do both the inspection documents as well as work with SolidWorks, you might have noticed that Inspection Standalone's mouse wheel is the different direction. Scrolling in brings the document towards you, and scrolling out brings the document away from you. You can now set it to be the same mouse directions as you experience in SolidWorks. Let's go ahead and take a look at these. So sitting here inside of SolidWorks, I'm going to open up a couple of drawings. Now with these two drawings, what I want to do is just go ahead and grab the specific data that we're looking for. Now, I'm going to show you exactly what it takes to make an inspection document here because, like I said, it's really just a couple of button clicks to make this happen. But it really does take care of a very monotonous process. So inside of SolidWorks Inspection, we simply start a new project. We have templates so that you can have settings that you set and forget and use every time. What we've added this time around is the ability to go ahead and control our extraction methods, either automatic or manual. We're going to do automatic first, but I'm going to prevent the automatic renumbering, which means when the numbers are initially set, those numbers will be the same on those balloons from this point on, regardless of edit. So let's go ahead and say OK. And you'll see that magically on the screen, every characteristic that we have specced out automatically gets numbers. Now what happens with this is very simple. When the balloon numbers are locked, we can go ahead and modify this document and roll with it as necessary. So we've got a 2 and a 3 over here on the side. We've got 18, 19. Well, I'm going to take this 7.25 and just simply delete it. Now, whenever changes like this happen, what we want to do is go ahead and make sure that that change is assimilated. And as you rebuild, you'll notice that that balloon stays. But by looking through our bill of characteristics over here, what you'll notice very easily is where the change actually took place. And here we have a red indicator. At any point, I can right-click and choose to accept this change or to ignore it as long as I'd like to. But more importantly, 19 stayed 19, and 24 and 25 stayed those numbers. Now on top of that, I can also go ahead and add a balloon or add a dimension quite easily. By adding this dimension in, it's not going to automatically be assimilated into our inspection document, but once again, you'll notice that as we scroll through our bill of characteristics, changes are easily identifiable. By selecting this particular balloon, I can choose to have it turned on, but what you'll notice here is that the sequential numbering automatically chooses the last or the next balloon at the end. Once again, all of the other sheets and all of the other balloons up to this point keep the same number and familiarity, so they're not changing right out from under your users. On top of that, I can choose another dimension and not show it, which is then going to remove the balloon for that. Now, even if we continue to edit and make changes, if at any point I'd like to go ahead and reselect that and show it, it will still use the same balloon number it used originally. Now the other part of this is not automatic ballooning and having more control over which dimensions that you physically want done. So down here in the lower right hand corner, I've got a few dimensions I'm going to deal with. Once again, we go ahead to inspection and we start a new project. This time, let's not say automatic, let's go ahead and say manual. Now when we do this, we've got a new add characteristics button up here. That allows me to now come in, and as I select a dimension, that dimension will get the next balloon in order. If I go ahead and select another one, of course, that's going to work as well. Now this is also effective if we window select. So if I grab multiple dimensions with a window, you'll be able to see each of those automatically getting a balloon in the proper order. And then if we go down to these dimensions here, once again, a window select enables us to quickly go ahead and select each of those. Now through this process, I have the automatic renumbering taking place. But if I choose to then deselect a dimension, you'll notice that the balloon on that dimension will then get removed. So very easy to control it, either automatic or manual, and the ability to put the dimensions and the balloons on the characteristics in whatever order makes sense for your business process. Our final subject today is 3D printing. Now, if you haven't had the pleasure of interacting with a 3D printer yet, don't worry, your time is coming. There's a lot of patents that have expired for many of the 3D printer manufacturers, which just simply means that that technology is now flourishing with other manufacturers. So inside of SolidWorks, we've got a lot of aspects that allow us to deal with the potential for digital manufacturing. Now, starting with Windows 8.1 and of course in Windows 10, we now have the ability to have printer drivers built right into the Windows interface. Now, with that said, you can now select a print operation directly within SolidWorks, and it'll give you feedback due to the build volume that you have from this particular 3D printer, and also some capabilities to auto fit and auto position in the best way on this platform. Well, one of the things that's critical is the wall thickness, and we can now identify in SolidWorks when there are thickness issues or gap issues. Now, each machine has different types of tolerances based on its method, and we want to make sure that the machine's wall thickness is going to produce a nice quality part and not be too fine for the detail or the capabilities of manufacturing. It's also based on the material and the layer height, so it knows what type of material and how thick your resolution is, and then that will either be a go, no-go process when it comes to that wall thickness. Also new is this file type called 3MF. Typically what happens with a CAD file is in order to 3D print it, it has to go into a preprocessor. So there's makerware, there's Connex ware that we would use from Objet or from Stratasys, and essentially you take the file in there and it produces the cut plot, essentially the layers, the thicknesses, the resolution, and all the pathing. Well, a 3MF file essentially has all that data built into it. It's a universal 3D printer file, which can avoid those preprocessors by sending it directly from the CAD product right out to any 3D printer. It's got the materials, the appearances, and the tessellated model data, which is the way that we display a 3D generated body inside of a CAD system. So I want to thank you all for coming to our third section of our What's New in SolidWorks 2017. What we covered on this one was our eDrawings, Treehouse, and costing applications, as well as 2D drawings, 3D model-based definition, the changes to our SolidWorks PDM platform, as well as what's new in SolidWorks inspection. And then we finished up with 3D printing, which is a topic that you're going to hear every single year from this point on, I'm sure of. So we have recorded this. We'll place this up on our website, but I want to thank everybody for spending some valuable time over the last few weeks with us, watching what we have to offer in this new installment of SolidWorks. Sure to be more breakthroughs coming October for SolidWorks 2018. But for now, if you haven't already done so, Service Pack 2 is available. Download that right away and move forward with your SolidWorks 2017 installation. Once again, I want to thank you on behalf of everybody at DASI Solutions. Without you, we don't exist, and that does not lose our minds at any point. Customers are the reason that we are here, so if you have any questions or need any assistance, please do not hesitate to get a hold of your sales account rep or your account managers. So once again, thank you very much from myself. Have a great day, and get a hold of us if you have any questions. Thank you very much. Take care.